Hello everyone. In this video, we will learn how to identify the nature of roots of quadratic equations even if we will not solve for the value for x. Now to do this, we will be using the discriminant formula, which has given us d is equal to b squared minus 4ac. Now take note, if the obtained discriminant value is greater than 0, it means the nature of the roots are real and unequal. If the discriminant value is equal to 0, it means the nature of the roots are real and equal. If the discriminant value is lesser than 0, the nature of the roots are imaginary and unequal. Now let's have an example. In this case, the value for A is 1. The value for B is 2, and the value for C is negative 15. Now, substituting this one in the discriminant formula, we will have 2 squared minus 4 times 1 times negative 15. Simplifying further, we will have 4. Negative 4 times 1 times negative 15 is 60. Adding together, we will have 64. 64 is greater than 0. So therefore, for this equation, the nature of the roots are real and unequal, in which if we will solve for the value for x, it's actually negative 5 and positive 3. Another example. In this case, the value for A is 1. There is no linear term, so therefore the value for B is 0, and the value for C is 4. Now substituting this one in the discriminant formula, we will have 0 squared minus 4 times 1 times 4, or this is 0 minus 16, or it's negative 16. Take note, the discriminant value is lesser than 0. Therefore, the nature of the roots for this particular equation are actually imaginary and unequal, in which if we will solve for the value for x, it's actually 2i and negative 2i. Another example. In this case, the value for A is 1. The value for B is negative 4, and the value for C is 4. Now, substituting in the discriminant formula, we will have negative 4 squared minus 4 times 1 times 4. So, negative 4 squared is 16. Negative 4 times 1 times 4 is also 16. So, 16 minus 16 is 0. In this case, the discriminant value is 0. Therefore, the nature of the roots for this particular equations are real and equal, in which if we will solve for the value for x, it's actually 2 and 2. Now look closely to the given quadratic equation. This is actually a perfect square trinomial. Therefore, discriminant value for perfect square trinomials are actually 0. Now, let's have another example. In this case, find the value of k so that the roots for 3x squared plus 4x plus k equals 0 will be real and unequal. Take note, the discriminant value for real and unequal roots should be greater than 0. So in this case, the value for A is 3. The value for B is 4. And the value for C is k. So substitute this one in this equation, we will have 4 squared minus 4 times 3 times k is greater than 0. So simplifying further, 16 minus 12k. Transfer 16 to the other side. Negative 12k is greater than negative 16. Divide the entire equation by negative 12, so we will end up with k. Negative 16 by negative 12 is actually 16 over 12. Now take note, at this part, the inequality symbol is greater than. In the next step, it became lesser than. Now why? It's because at this part, we divide the entire inequality by a negative term. So take note, the rule in math is that when you divide or multiply an entire inequality by a negative term, you should always flip its inequality symbol. Now at this point, we can still simplify 16 over 12 into 4 over 3. So therefore, for 3x squared plus 4x plus k to have real and unequal roots, the value for our k should be lesser than 4 over 3. Now, what are numbers lesser than 4 over 3? So, it could be 1, it could be 0, or it could be negative numbers. So, let's try to check. And let's have k as negative 1. Now, let's substitute k here with negative 1. So, at this point, this is 16. Negative 4 times 3 times negative 1, it's actually 12. Combining this, we will have 28 is greater than 0. So, that's how are you going to check. Now, let's have another example. In this case, find the value of k so that the roots for 4x squared minus 3kx plus 1 equals 0 will be real and equal. Take note, discriminant value for real and equal roots should be equal to 0. So, this will be our equation. Discriminant is equal to 0. At this point, the value for a is 4. The value for p is negative 3k. And the value for c is 1. Now, substituting this one here, we will have negative 3k squared minus 4 times 1. This is actually 9k squared, and this is negative 16. Transfer 16 to the other side, it will become 16. Divide the entire equation by 9, we will end up with k squared equals 16 over 9. Get the square root to both sides, so therefore the value for k should be positive and negative 4 over 3. So therefore, for 4x squared minus 3kx plus 1 to have real and equal roots, the value for our k should be positive and negative 4 over 3. Another example. In this case, find the value of k so that the roots for 2kx squared minus 4x plus k equals 0 will be imaginary and unequal. Take note, discriminant value for imaginary and unequal roots should be lesser than 0. So, discriminant should be lesser than 0. In this case, the value for a is 2k. The value for p is negative 4, and the value for c is k. Now, substitute this one in this particular equation. We will have negative 4 squared minus 4 times 2k times k should be lesser than 0. Simplifying further, we will end up with this. Transfer 16 to the other side, it will become negative 16. Divide the entire equation by negative 8. We will end up with k squared. Negative 16 by negative 8 is positive 2. Take note, here it's greater than. It became lesser than in the next step. It's because we divide the entire inequality by negative 8. At this point, get the square root to both sides. So the value for k should be lesser than plus and minus square root of 2. Or k should be lesser than negative square root of 2, or k should be greater than square root of 2. So these are the possible values for k, so that 2kx squared minus 4x plus k will have imaginary and unequal roots. So that's all about identifying the nature of roots even if we will not solve for the value of x. Thank you.